Welcome once again to another time value of money video. Today we're going to look at perpetuities. And a perpetuity is like an annuity except for one thing. The number of cash flows are infinite. So perpetuity is like an annuity. The only difference is an infinite number of cash flows. The interval between payments is fixed. The size of the cash flows are the same. It's just rather than having a finite number, there's an infinite number of them. Okay? So if we wanted to do a cash flow dateline for an annuity, maybe paying, starting at date 0 and paying, X dollars, it would look like this. And we tend just to put a few dots there at the end, indicating it just goes on forever. And so perpetuity. So now, because perpetuities never end, it should be obvious that the concept of the future value of a perpetuity doesn't make sense. It never ends. But what does make sense is the concept of the present value of a perpetuity, measured in dollars, the present value of the perpetuity. And we're going to see that the application formula for perpetuities looks like this. Present value of the perpetuity equals perpetuity cash flow times present value interest factor for a perpetuity. So, kind of easy in that the concept that I developed for you in the last video with present value interest factor for an annuity, the same idea applies here in developing this. In other words, if let's say I've got this perpetuity, it never ends, and let's say we have this perpetuity, $10, 10 million maybe, whatever, it goes on forever, and I'm interested in the value of this at date 0. Okay, I like to put values above the dates and actual cash flows below the dates. And if I'm having I call it a bad logic day, let's say the opportunity rate of return, the discount rate is 10%, just because it's easy to work with, right? Discount rate. And then, I might say, if I'm having a bad logic day, the present value of this perpetuity equals this $10 times 1 over 1.1, and then plus this $10 times 1 over 1.1 square, plus this $10 times 1 over 1.1 cubed, and then it would hit me, this never ends. I'm not going to get anywhere doing this type of analysis. But you get the idea. So here the idea is you can factor out a 10, but what you have here is 1 over 1.1 plus 1 over 1.1 square plus 1 over 1.1 cubed plus it never ends. I mean, you can't really do that algebra, but that's the idea. It never ends. So, what can we do to understand this thing? Well, bright people a long time ago came up with the idea. They said, listen, let's have a definitional equation. I'll call it equation 1, Roman numeral 1. And it says, rather than the sum, as they do in infinite series mathematics, we'll name our sum. The present value of a perpetuity is defined as, remember, this is the interest factor. Okay, I'm sorry, not the present value of the perpetuity, the present value interest factor for a perpetuity. Okay, sorry about that. Present value interest factor for a perpetuity is equal to, then we just it's 1 over 1 plus r plus 1 over 1 plus r squared plus 1 over 1 plus r cubed plus ... Never ends. Never ends. That's the definitional equation for present value interest factor for a perpetuity. Remember, what we're doing is we're solving for this thing right here. this thing right here. Okay. Well, Roman numeral 2, another equation. Let's multiply both sides of the equation by a factor. Let's use 1 over 1 plus r. So I'll have 1 over 1 plus r times PVIFP here. And then over here, multiplying each term by 1 over 1 plus r, I get 1 over 1 plus r squared. And this becomes 1 over 1 plus r cubed. And this term becomes 1 over 1 plus r to the 4th power plus, it never ends. And now, remember, if this equals this, and this equals this, therefore logic tells us that the difference in the left-hand side has to equal the difference on the right-hand side. So let's do 1 minus 2. So we have a 1 minus 2. So over here on the left-hand side, I have PVIFP minus 1 over 1 plus r times PVIFP. And 1 minus 2 over on the right-hand side, let's see. Well, I have some canceling that's going on. This cancels with this. This cancels with this. You'd agree that the next term here cancels with this. And then because these both go on forever, every term down here is also up here. So they'll just cancel forever, and we're left with one term. It's that. And since it's 1 minus 2, it's positive, so 1 over 1 plus r. Okay, so now I've got my equation. Here's my equation we're going to work with now. So I'll multiply, I'm going to multiply every term by 1 plus r. So I'm going to have 1 plus r times PVIFP. And then here, if I multiply this by 1 plus r, I get 1. So I have PVIFP, there's a minus sign, so minus PVIFP. And if I multiply this term by 1 plus r, I get 1 plus r over 1 plus r, 1. And so let's see what we have here. I'll distribute the PVIFP over this. I've got PVIFP times 1 is PVIFP plus r times PVIFP minus PVIFP equals 1. And these cancel. And so I've got r times PVIFP equals 1. Therefore, PVIFP equals 1 over r. And there we go. There we have it. That is our computational formula for a present value interest factor for a perpetuity, 1 over r. And our application, so this is the computational formula. So in the table that I had shown to you right here in the last video, we'll now add number 5, present value interest factor for a perpetuity. And the computational formula is just 1 over r. And then the application formula here is present value of a perpetuity equals perpetuity cash flow times PVIFP. And there we go. So that's our 5th interest factor. And it's our second multiple cash flow stream, by the way. Our first multiple cash flow stream was an annuity, and we dealt with annuities with number 3 and number 4. And now we see our second multiple cash flow stream, a perpetuity, and we deal with that directly in number 5. So that's enough for this video. Thank you for watching.